to E.
Yep. Not including E. And negative.
From E to J.
So we express it in this form over here. The velocity is greater than 0 from, not including, no, it does include A to E. It's equal to 0 from, at E, and it's less than 0 E to the end of the problem. Let's see better days. Oh, there we go. Questions on velocity? Now let's get to the fun one. Or actually we can do plus. All right, acceleration. Remember the rules for acceleration. If an object is speeding up, it's the same sign as velocity. If the object is slowing down, it's the opposite sign. Or, when the net force is in the positive direction, it's positive. When the net force is in the negative direction, it's negative. Or, it's the same sign as the change in velocity. So when is it going to experience forces? At what point in this will it experience some force other than the weight and normal force, which is balanced out?
When there's friction?
Yes. Yes. When there's friction and
Against the wall.
yes. So we're going to have some force in here and here, but nowhere else is any force acting on it. So we've got a whole bunch of zeros here. So it first touches friction from B to C. So anything before it touches friction, acceleration is 0. Afterwards, until we get to the wall. Then after the wall, until we get back to friction. F is the wall. And then after, and then friction ends at H. All right. Now we're zeros. Now these are the only places where I can jump from positive to negative. I'm not always going to jump from positive to negative, but if I do, I have to go through 0. All right, so when the puck is moving this way, which way is the friction acting on it? All right, good. Yeah, all right. Got a number of hands pointing that way for friction. Therefore, when it's going over the friction here, is the force positive or negative?
Negative. Positive. Negative.
Negative. Friction is acting this way. The puck's moving that way, so we're still talking from time B to time C. Puck's moving this way, friction's acting in the negative direction. So my acceleration will be negative in here. As the puck goes over friction, it's going to speed up or slow down. So if it's,
Slow down.
yeah, all right, so the sign has to be opposite of the velocity. Well, my velocity is positive in this region, so my acceleration is negative. It means I'm slowing down. All right, it hits the wall. Indeed, for such as the wall, E is at maximum deflection, and then F is the last moment is touching the wall. Which way is the wall exerting a force on the puck?
To the right.
To the left, opposite of the puck, which is moving to the right.
Oh, well, okay, you're just looking at from what, D to E? I said while it's touching the wall, and then I heard various answers. You said while it's moving to the right.
So it's moving to the right, which means the wall would oppose it going to the left.
For the entire time, or just while it's moving to the right? For the entire time it's touching the wall.
Right.
Okay. So you're saying for the entire time it's touching the wall is pushing it that way.
Correct.
Not enough to bet your grade on it. Your confidence is not. Someone want to help him out? For the entire time the puck is touching the wall, is the wall exerting a force on it that way?
Yes.
Yes. It's touching the wall from D through F. So if the wall's pushing on the puck that way, is that positive or negative?
Negative.
Now, when it first touches the wall, it is going to slow down because it's moving to the right. It has to slow down in order to stop. So when it first touches the wall, so this is from touching the wall to stopping, it's slowing down. Velocity and acceleration are opposite signs. After it hits maximum deflection, it then starts moving back in the other direction, so it's speeding up in order to move back, because you can't get lower than 0 in terms of speed. And so from E to F, not including E because it stops there, from E to F it's speeding up, and so velocity, acceleration are the same sign. They're both negative. And now the puck goes over the friction area again. Is the acceleration positive or negative?
Positive.
Why? Should I erase this?
I'm trying to think
No, because it's positive. Because it's going that way. Because it's going that way. I don't know.
Because what's going that way or that way?
The foot. The foot.
Okay, the puck's going which way?
Oh my god.
The puck is going left, so friction wants to go right
Yes.
because it's opposing its the motion.
Yes.
I can't word it right, but yeah, you know what.
No, you did word it right. The puck is moving this way, friction opposes that motion, so friction is that way, so it's positive. Friction's positive, acceleration's positive. Or, as the puck goes over the friction, it slows down, and so velocity and acceleration are opposite signs. Velocity is negative, acceleration has to be positive. So 0, 0, negative, 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 0, negative, 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 negative. 0, plus, 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 0, 0, 0, 0. All right. So, let people finish writing stuff down, and then we will add a couple extra comments. All right. Let's look at acceleration a slightly different way. I mentioned that acceleration is always in the same direction as the change in velocity. So I'm just going to make up some velocities here. So let's say that it starts moving this way at 20 meters per second. So in green here, velocity in meters per second. Address this with contrast better. Yes, it does. It hits the friction. There's nothing to slow it down until it gets here, so it's still going 20. It's going to slow down, so we'll just say 15. It gets to the wall, still going 15, but it's 0 at this point, and then bounces back, so this will have a velocity of negative 15, because it's going in the negative direction. It's cruising along at negative 15, but it hits friction right here, so it's going to slow down, so negative 10, negative 10, negative 10. Change is always final minus initial. What is the change in velocity between A and B?
10.
How'd you get that?
0.
0, yep. Did you say 10 the first time?
No.
Okay. What's the change in velocity here?
5.
Not 5.
Negative 5.
It's final minus initial, it's 15 minus 20, negative 5. Acceleration's negative here. In this region, change in velocity,
0.
from D to E, 15 to 0.
15.
Negative.
Negative 15.
Acceleration's negative, from 0 to negative 15.
Positive
15.
Not positive.
Negative.
It's final minus initial, it's negative 15 minus 0, which is negative 15.
Oh.
In this region,
0. Negative 0.
either one. In this region,
Negative 5. Positive 5.
positive 5. Negative 10 minus negative 15, it's the same as negative 10 plus 15, which is 5, positive 5. It's positive, acceleration's positive here, as we reflected over there, and then 0 and 0. A different way of looking at the same thing. You should be able to look at it all three ways and get the pretty much the same answer. Looking at it from is it speeding up, slowing down? So is acceleration the same sign as velocity, opposite sign of velocity? Works really well, except at turnaround points. But force works really well everywhere. And looking at the change in velocity works really well in between. Doesn't work as well at B, what's going on. That's when you have to read the text to say that, oh, there's friction at B, but not before. All right, questions to here?
Wait, so what was your starting point to start, like, subtracting?
Starting point was kind of A.
Okay, okay.
Problem begins.
Okay, I get it.
All right, now I know what you're thinking. All this is great, but where's the math? So let's do some math. A car is traveling along a straight road. At constant acceleration. There's two key things in that first sentence. One, straight road, which means we're dealing with a one-dimensional problem. And constant acceleration, the math we're about to do assumes constant acceleration. The initial velocity of the car is positive 20 meters per second. After 7 seconds, the velocity of the car is negative 15 meters per second. So that's the problem. There's enough information now to solve for all the things I'm about to ask. Velocity, acceleration, average velocity, We'll start out step by step. I start out at 20 meters per second, I end up at negative 15 meters per second. What is my change in velocity? Before we get that far, do you need me to help with something?
It was number 3.
Here?
Yeah.
That's average velocity, that's the V, the velocity symbol, and that's supposed to be
And the
AVG.
bottom is average.
Yep, that's supposed to be average also. Any other questions before we get back to the map? All right, change in velocity. How do you find change?
Velocity 2 minus velocity 1.
Say it again.
Velocity 2 minus velocity 1.
Okay.
Like minus 15 minus 20.
Velocity final minus velocity initial, or velocity 2 minus velocity 1. And so negative 15 minus 20
Minus 35.
meters per second. I don't have to keep track of units as I go, but I need to make sure I have units at the end. So negative 35 meters per second. All right, acceleration. Acceleration, since it's constant, it's the instantaneous acceleration, it's the average acceleration, either one. But the acceleration is the change in velocity over the change in time. Well, I know what the change in velocity was, I just solved that. And change in time, that's how much time took place. For my velocity to change, negative 35 meters per second, how much time passed?
7 seconds.
Yep, and that's given in the problem. So the math piece is negative 35 divided by 7. That's the math. So negative 5. And then the units.
Meters per second squared.
Acceleration is done. So let's take a look at that slightly differently. What acceleration tells us is that the velocity changes negative 5 meters per second every second. So if I set up a table, we'll do time and velocity, velocity in meters per second, time in seconds. So 0, 1, 2, 3, 4, 5, 6, 7. My velocity starts out at 20. I'm going to lose 5 every second that passes, so after 1 second, 15. After 2,
2, 5, 0, minus 5, minus 10, minus 15.
the fact that we ended up at 7 seconds, we ended up with what the velocity was, means we've done something right. Now we'll want to find average velocity. So how do you average?
Add them all up, divide by your number.
Okay?
But probably we should take minus 15 as just 15.
Like take minus 15 and what?
Like take it as model without minus, right? We can,
No, you need the minuses in there. So add them up and divide. Go for it. It's like a lot of favors being placed in just a couple.
add all of those.
Yeah, we're finding average velocity, so you add them up and divide by however many numbers you got.
How far I follow computation. That's wonderful.
Emily, you don't look like you're happy with your answer.
Cause it's a long decimal. 2.85.
Yeah, no, there's a mistake there. I think you made a common error.
Ah,
I believe you added them up correctly, or at least close enough. I think you divided by the wrong number.
I see.
It's a quick check, how many numbers are there?
So it's 2.5.
Yes, there are 8 numbers. A lot of people will divide by 7. If you're not dividing by 7, you're dividing by, there are 8 of them here, because the 0. The lesson, the moral of this is, show your work.
Mine says error.
Huh. Work at math? What did you do?
I added on the old and then the first. You just divided by 0?
No, you divide by the number of numbers you have, you're just like a
Oh,
regular
so
average.
8.
Yeah, so you divide by 8. Okay. Yeah, dividing by 0, the math people haven't figured out how to do that yet. I'm assuming you got.
Yeah.
Answers to later, yes.
Yeah.
Take a little potty break.
You're working on it. All right. It is still running, okay. Now, this technique of adding them all up and dividing by the number works if, 1, acceleration is constant, and 2, you have even increments here. These are every second. We could do every half. We could also do every half second if we wanted. There'd just be a lot more numbers. But the question is, what's so special about every second? Suppose we did every